All right, ladies and gentlemen, we're going to look at perpendicular lines. So parallel and perpendicular kind of go together in a sense that the slope is what matters. So let's take a second and look at what we have here. So perpendicular lines intersect to form 90-degree angles. Remember, 90 degrees is this. So they will form 90-degree angles when two lines intersect to form perpendicular lines. Now, when we talk about the equations that are perpendicular, it's about their slope. So the slope must be, and this is kind of odd, opposite reciprocals of each other. So what I mean by that is, let's say we have a slope of 3/4. The opposite reciprocal of that is -4/3. So remember, the opposite is changing the sign. The reciprocal is flipping it. So if we have, just 2, the opposite reciprocal of that would be -1/2, and so on and so forth. So we'll look at a few of those today. So here we're going to write an equation in slope-intercept form of a line that's perpendicular to this one. So we have a slope of 1/5. So perpendicular would have to be a slope of negative because it's going from positive to negative, and then 1/5 becomes 5/1, or just 5. So when I can still have the same, I believe I can still have the same y-intercept, and it would be perpendicular, but it's going to happen at that point. So we can leave it just like that. So we can have y equals -5x minus 4. We can have different equations of the line. We can have -5x plus 1, and so on and so forth. So let's graph this. So let's say we have y equals -5x. Well, let's actually do the 1/5 first. So we have, in parentheses, let's do 1/5 x plus 4, I believe. There's that equation. Now let's do y equals -5x plus 4. So you can see here that these lines are perpendicular. Now, you've got to be careful in this case with Desmos, because if the window changes, if you notice, the window is even here. It goes from 10 to 10 on the x-axis and 10 to 10 on the y-axis. If that window changes at all, you can see that it may not look perpendicular later on. I'm trying to see if I can make it look not perpendicular, but I guess Desmos is pretty user-friendly like that. But you can see here that we do have those right angles. Therefore, these lines are perpendicular. Let's try another one. Here, this one is a y equals. Y equals is a horizontal line because it crosses the y-axis. So if I need a line to be perpendicular, that means I need a vertical line, correct? Vertical would mean x equals. And let's just go ahead and say x equals -2. Just because it's the same value doesn't matter. It can also be x equals 3, x equals 1/2, whatever. They would all form perpendicular lines. Let's see what we have. So y equals -2. There's that one. And then the next one just needs to be x equals any number, and I'm just going to go with -2. So there again is our perpendicular pair of lines. All right, now we're going to continue this way, except now we have to do a little bit of manipulating because this equation is not in the correct format for us. So I need to get y by itself in order to get slope-intercept form and to know what my slope is. So I'm going to start by subtracting 5x. So I have -4y equals -5x plus 3. I'm going to divide by -4 everywhere. So y equals, now negative divided by negative becomes a positive, so this would be 5/4 x minus, because of the negative, 3/4. So that means our slope is 5/4. If I want the opposite reciprocal, It's going to become negative 4 over 5. So in this case, our y-intercept's at negative 3/4. As long as the slope changes to 4/5 x, it will automatically be perpendicular, because remember, it's the slope that makes the steepness of the line, while the y-intercept is just where it crosses the y-intercept. So really, this could be any number for b. It doesn't have to be negative 3/4. It can be 1. It can be 3/4. It could be whatever you want it to be in this case. All right. Now we're going to write an equation in slope-intercept form that is perpendicular and passes through this point. So this is where it can get a little bit tricky. So our slope is 1/3. So a perpendicular slope is going to be negative 3. So what I'm going to do is use point slope form to help me here. So remember, this is x, this is y, so this would be y minus 4 equals negative 3 times x minus 2. All I did was put the point where it belongs, which is why we practiced that as much as we did. And now I just have to rewrite this. So y minus 4 equals negative 3x plus 6. Now I'm going to add 4. So y equals negative 3x plus 10. Our slopes are opposite reciprocals because we went from 1/3 to a negative 3, and the y-intercept is at 10, which really means nothing unless we go to graph it. So let's see. Y equals 1/3 x minus, which we will. 1. Let's get rid of that extra. X minus 1 is our first one. The next one is y equals negative 3x plus 10. So if you notice, as that y-intercept, look, if I change that y-intercept from 1 to 10, all it's doing is shifting the line up and down. So in this case, it is that pair of lines are perpendicular. The slopes are opposite reciprocals. They just have different y-intercepts. And they can have the same y-intercept as well. Don't forget that. All right, here's our last one. So we have a slope of 2. So the opposite reciprocal would be a negative 1/2. We have the point 1/8 that we want to have that line pass through. So let's use our point slope. So y minus 8 equals negative 1/2 times x minus 1. So now I'm going to simplify by getting y by it to give y by itself. So y minus 8 equals negative 1/2 x plus 1/2. Now I'm going to add 8. So now I have y equals negative 1/2 x, and it should be 8.5, which ends up being 17 over 2, I believe. So 8 times 2 is 16 plus 1 more is 17. So that means this line will be perpendicular to this line. So you can always check your slopes to see if they're perpendicular. So for example, if you go from 3 to just negative 3, that's not perpendicular. 3 must go to negative 1/3 in order for it to be perpendicular. So keep that in mind, that there's a difference between just opposite and opposite reciprocals.